So they say in the diagram below you have ABC, which is a rhombus, keyword rhombus. Then you need to know all the properties of a what of a rhombus. Now, what are the properties of a rhombus? All the properties of a parallelogram. And what makes a rhombus so special is this one. The diagonals bisect each other at perpendicular. That's what makes a rhombus so special. The diagonals, they are going to bisect each other at the what? At perpendicular. Meaning, in other words, I can safely say to them, AC is going to be perpendicular to what? To DF. Or I can tell them, CF is going to be perpendicular to what? It's going to be perpendicular to DF. What else should we know? We also know what this one is going to be parallel to this one, right? And then we also know which this one is going to be equal to this one, it's going to be equal to this one, also going to be equal to this one. And then this one is parallel to this one. And then we also know which this one is going to be equal to this one. This one is going to be equal to this one. So those are the properties of a what? Of a rhombus. Which one am I going to use? The one that I'm going to be using here, they say to me, calculate the value of Q. Which one am I going to use? I am going to use the fact that if I can say the gradient of CF multiplied by the gradient of DF, they're supposed to give me what? -1. Where do I get that? There's a 90 degrees here again. What do you know about 90 degrees? They are what? They are perpendicular. So I'm going to start by telling them which DF is perpendicular to what? To FC. It's true, they're perpendicular. Where do I get that? I get it from the fact which this thing here, it's a what? It's a rhombus. Because the diagonals, they bisect each other at the what? At 90 degrees. It's a property of a rhombus. Then are they going to give you the property of a rhombus? No, we know you need to know the properties of a rhombus. And I'm telling you, one of the properties that makes a rhombus so special, unlike a parallelogram, a parallelogram only has diagonals bisect each other. A rhombus says we bisect each other and then we form what? A 90 degree. So it means that I am going to look for M of FC. If I look for M of FC, it's going to say that I have Y of F minus Y of C all over X of F minus X of C. And then you go and check there, what is this thing here that you have? What is Y of F? Y of F is -1. So I'm going to have -1 open bracket minus. So I'm going to have minus open bracket. What is C? -3. All over. X of F, 2. Minus open bracket, it's 3. And then if you simplify this, what you get as your answer? -2. Are you sure? So we get -2. Sharp. Okay, next. What is it that we're going to look for? We're going to look for M of DF. What is going to be M of DF? I'm going to look at the coordinates of D, and then I'm also going to look at the coordinates of F. So we're going to have Y of F minus Y of D all over X of F minus X at D. What is X at F? Oh, Y at F. What is Y at F? -1. Minus open bracket. It's Q. No, it's not A, by the way. All over. Yeah, this is Q. We also have all over. It's 2 minus open bracket -4, like this. And then what you get as your answer for this?
Close bracket.
So you're going to have a negative and a positive, agree? So you're going to have -1 minus a Q all over 6, like this. Now the black and the red are not equal, but they're going to give us what? -1. Why? It's because these two are what? Are perpendicular. Why am I saying they're perpendicular? It's because I'm using properties of a what? Of a rhombus. So I am going to go on and say I have the following then. I need to close my bracket. Which one?
2 minus open bracket -4.
-4, or you want me to close this one?
Yes.
Okay, I am going to tell them which I have minus, I am going to have M of FC multiplied by the M of its DC, DF. These are going to give us what? -1. So this is DF, okay? And then we know what is M of FC. M of FC is what? It's -2. Ne?
Yes.
Multiplied by M of DF
-1 minus 1.
is -1 minus Q all over 1 all over 6, which is going to be equal to what? -1. We still fine, Anish? Okay, I'm going to continue somewhere here. Ne? Okay, from here we said, okay, this one, it means which is all over 1. Anish. Then if we multiply throughout, we're going to have -2 multiplied by -1, it gives us what? 2. We're going to have -2 multiplied by -Q, it gives us what?
Positive 2Q.
Plus 2Q. 1 multiplied by 6, it gives us what? 6. Which is going to be equal to what? -1.
Over.
This one multiplied by this one, it gives us 2 plus 2Q, which is going to be -6. Ne? You take this one to this other side, it says 2Q is going to be equal to -8. You divide by 2, you divide by 2, it says Q -4. And then you come and check what it makes sense. Ne? It should make sense, guys. Ne? You are in this quadrant here. Is it possible for y to be negative here? It makes sense for y to be negative. Ne? So I'm going to tell them which here we have -4. Ne? So we come and put which here we have what? -4. Everyone is happy then?
Yes.
Okay, we are done with that one. Number 2, they say calculate the area. Ne? They're going to be calculating the area of triangle CFD. Now, CFD is a right angle triangle. Good news for us in grade 11, in grade 10, the only area that we're doing is the one of a right angle triangle. We're going to do other areas in grade 11, whereby we can calculate the area of something which is not a right angle triangle. But for now, we're only going to calculate the area of a right angle triangle. Now, how do you calculate the area of CDF? You're going to tell them which is the area of triangle CDF is going to be given by half, no? Multiplied by the base, multiplied by the perpendicular height. This formula for area doesn't change. Tina, in grade 11, in grade 10, we only calculate the area of a right angle triangle. We'll calculate other areas in grade 11, but for now, we're only going to calculate this area. So we need to know what is going to be our base. We need to know what is going to be our height. Né? So what is it that you have to do here? You have to know. This is what you have to know. You need to know what is going to be the length of CF. You need to know what is going to be. Remember here, look at this thing here. I'm sure there's a 90 degrees here. Né? In 90 degrees here, you are going to have your hypotenuse side. Once you have a 90 degree, you have your hypotenuse side. Né? The hypotenuse side cannot be the base, cannot be the height. Né? The hypotenuse side cannot be the base, cannot be the height. So what are you going to be left with, man? You are going to be left with FC and DF. Né? So those two can either be a height, it can also be what? Be the base. So what have I excluded? I only excluded the hypotenuse side. I am going to look for the length, not the gradient, the length. You need the length here. So we're going to look for the length of FC. How do you get the length of FC? From calculating the length, we said FC all squared is going to be given by X at F minus X at C all squared plus Y at F minus Y at C all squared. And then after that, if you do that, what is it that we're going to get? We are going to get X at F. What is X at F? It's 2 minus open bracket, 3 close bracket, all squared plus. What is Y at F? It's -1 minus open bracket, minus 3 close bracket, all squared. And then you can come and say square root.
Yes.
If you say square root, what is going to be FC? Football Club Barcelona.
0 to 5.
Yes. What you get FCS? Square root of? Square root of 5. Okay, we get square root of 5, and then we'll come and write square root of 5. So we're going to tell them which we have square root of what? Of 5. What is this? This is our FC. What else are we going to look for? We're also going to look for, except the hypotenuse side, Danish. We looked for FC, now we're going to look for what? For FD. So what is going to be FD? We're going to tell them which FD all squared, Danish, is going to be given by X at F minus X at D all squared plus Y at F minus Y at D all squared. Okay, let's substitute then. X at F, it's 2, minus open bracket, minus 4, close bracket, all squared, plus we have minus 1, minus, we also got minus 4 SQ. So it's going to be minus 4, close bracket, all squared. And then you say square root, Amish. What you get as your answer? Yeah? Huh? This one. No, we know this one. I could have calculated it here. We got it as minus 4. Yes. We already got it. When you go to the next question, you got it. It's 3 square root 5. So I'm going to say which you have 3 square root of what? Of 5. Then you can go back to your area. Now on your area, you're going to tell them which I have 1 all over 2 multiplied by root 5 multiplied by 3 root 5. Now let's, what is the key here? The only thing that you can't use is the hypotenuse side. Which one is the height, which one is the base? It doesn't matter. You just have to substitute. One of them is the base, one of them is the what is that? Is the height. Height and the base cannot be the hypotenuse. So now we're going to be using a right angle triangle. If you have a right angle triangle, it means you're going to have a side which is going to be opposite to the 90 degrees. And then we call it what? The hypotenuse side. You type this in your calculator, you get an answer. It's 15 all over what? All over 2. Now, since it's an area is going to be units all squared. Here, this one here, it's root 5 units. Ne? And then this one here is also 3 root 5 units. And then unit and the unit, they're going to give you what? Units all squared. That's an area. Now, I'm going to go to the last one, area of a rhombus. Ne? Calculate the area of a rhombus. A rhombus, it's a rectangular in a shape. So how to get the area of a rectangle? How to get an area of a square? Area of a rectangle or area of a square? How to get it? It's length times breadth. Yeah, on number C, look at this number C. I am going to tell them what the area. The area of a rhombus is going to be area of a rhombus is going to be equaling to length times what? Times B. Ne? So it means I'm going to tell them what I want this length multiplied by this length here. This length multiplied by this length is going to give me the area of a rhombus. Now, you can also remember which this length and this length, they're equal. If these lengths are equal, I just have to calculate the length of DC. I don't know what is the area of the length of DC. I can get it. There are many ways in which I can get it. I can use equidistance formula to get this. Or if I don't want that, I can use theorem of Pythagoras and say to them, okay, but now DC all squared, since this is a right angle triangle, I'm sure this is a right angle triangle, is going to be given by FC all squared plus DF all squared. Yeah? But I know what is FC. I've already calculated it. I calculated this as root 5. Yeah? And then plus, this one here is going to be, I think it was 3 root 5 all squared. And then I am going to say square root after that. Let's check if I'm correct. It was 3 root 5 and root 5. Okay. Now, guys, if you don't want to do it that way, you can still use the distance formula. I'm sure you know how to calculate. Yeah. What are we going to get for this one then? If you say root 5, it gives us 25. 25 plus, I know it's 5, this one. Root 5 is 5 plus 9. Root 14. This one, what you get is it's 5, answer. It's 5 square root of 2 like this. Ne? Yeah, here's what I'm going to tell them, man. Look at this. This is 5 square root of 2. Ne? This is 5 square root of 2. This is 5 square root of 2. This is 5 square root of 2. But how do you know that side? Because this is a rhombus. If it's a rhombus, all sides are what? Are equal. Then if I want to get the area of this thing, it means which I am going to tell them which it's going to be 5 root 2 multiplied by 5 root 2. And then it's going to give you what as a final answer? It's 5 multiplied by 5. It gives us 50 units squared. Now you're going to do activity number 10. Here it is. Yes.